Well, hey YouTube, it's Elvis Ammo here. Hey, today I want to talk about a pretty cool subject. It's kind of special, something I've been working on for some time. I want to show you something. Take a look at this. Look real close. Alright. You see that? There's something definitely different about these bullets, and I'm going to reveal that. Not to drag this out, but I love this new sign that I made up. There is something different about those bullets. Did you catch it when I showed them to you? I'm going to show them to you again. Tell me if you see anything different. Do you see anything? No, I didn't think so. But there is. There is something very different about these bullets. You're looking at them and you're like, okay, they're powder coated bullets. And they are. But the way that they're made is a whole lot different. For the longest time, now there's been information about this subject for a long time, but I've never seen a solution to the problem, and that is on our BHN. Now, you know, we spend a lot of time casting our bullets, and then we water quench them, and then we powder coat them. We put them in the oven, 400 degrees for 20 minutes. Then we take them back out, and we load them, and we shoot them, and things seem to work just fine. And that's the reason I've never, on this channel, I don't know if any channel has, to be honest with you, but I know in different forums this subject has come up. But whenever you powder coat your bullets, let's say you got your wheel weights, for instance, like I do. I use my clip-on wheel weights. I cast my bullets. If I want the bullets to be extra hard, I water quench them, and then I powder coat them. I put them in the oven, 400 degrees for 20 minutes. I take them back out, load them up, and shoot them, right, or size them, whatever. Well, what's been happening is, and this is the reason I didn't bring the subject up before, is what's been happening is when we quench our bullets, we gain a substantial amount, especially if you're using like clip-on wheel weights, where you have your standard ingredients like antimony, tin, and arsenic. Those are usually common ingredients found in this type of lead, and we water quench them. And for instance, this particular, I separate my clip-on wheel weights, from my stick-on wheel weights, and I end up with a pretty good hardness. After water quenching, I can have, I probably average about 21 BHN, and then there's a whole nother subject about the BHN increasing or decreasing over time. I'm not going to get into that at all in this video, but for instance, let's see, I cast some bullets here, 400 degrees for 20 minutes, and my raw bullet, just shortly, within an hour after I cast them, I was already reading 21 BHN on my hardness tester, on my Lee hardness tester. That's what I'm using. So and then I powder coated them, and I think I checked it about a day, not even 24 hours later, and I was at about about 11.5, 12 BHN, all the way from 21, so almost dropped in half of the hardness. Now, over a period of a week, for sure, a few days to a week, that will increase to, it varies a little bit, obviously, depending on the percentage of ingredients that you have in your lead. It may increase, to 15 or 16 BHN, 15 BHN, 14 BHN. It varies a little bit depending on the antimony, tin, and arsenic, or whatever you have or you put in your lead. So anyway, so you lose a lot of hardness, because by powder coating our bullets, we are tempering the lead, just like welders know. If you're welding on a piece of steel, you could very well soften that steel where that weld is, and anywhere around where that weld is, because the temperature rises to almost the melting point as you're welding it. So we're tempering our bullets. But the reason I didn't bring this up as a subject in another video is because I didn't want to be kind of a spoiler and freak people out about powder coating their bullets. There's no reason to, because in the end, ultimately, we know that our bullets are shooting just fantastic. But in this video, I'm going to show you how we can have more control over the hardness of our lead. And for the longest time, I've tried to find out different ways of coating bullets. I've spray painted them. I've done all kind of crazy things. I've heard Thorzak 777 mention floor wax, on some bullets. Now he's not a powder coater, but a luber. But regardless, I've thought of all kinds of different methods that we could use to coat our bullets and not heat them up so much, or not heat them up at all, to retain our BHN that we have after water quenching, that kind of thing. So not to get too deep into this subject, because this video is really about my new method, and this subject, I'm sure, will be very fluid. It will probably be talked about in some of the forums and other channels, and you guys will be testing this theory out, or not this theory, but this method. It's not a theory anymore. You guys can give me some feedback, please, just as you always do. But so what I've done is, it's like pulling teeth, finding different, a ultra low heat method of coating our bullets. So I was like, I'm not pulling my hair out anymore. I'm going to try some different stuff here. So I took the powder coat that we already have, the Ford Light Blue, and I kept powder coating until I found the lowest temperature that I can powder coat these bullets at and still have flow out. So the bullet, the powder coat flows out over the bullet, and and you get this sheen on it, and it's melting in, and that it stays in the oven long enough to cure, to where the coat is hard enough still to be able to use it just like we always do. And I accomplished that. And this is a big deal for me. It's something I've worked on for a long time and kind of beat my head against the wall with, and I wasn't sure if I was ever going to come up with it. But I didn't really want to talk about the tempering of our bullets in the oven, because I never had a solution for it. So I don't like complaining about something until I have a solution for it, is really where I'm coming from here. Which isn't a big complaint anyway, because this stuff works. So here's what I come up with. I take my, here's the new method. And I'm going to do some follow-up videos on this subject, and I'm going to show I'm going to walk you through an actual powder coating method. But I think I have enough information where I can sit here and talk about this and give you enough information to get started right away. The cool thing about this new method is you already have everything that you need. There is nothing new that you got to buy. There's nothing you got to change, except for the temperature of your oven. So what I've done is I've figured out the minimum temperature that you can get flow out and harden up your bullet. And so after checking many temperatures and then checking the hardness of the bullet to figure out if the BHN has changed at all, because that's where I was going with this. I wanted to know at what temperature can I cure the powder coating on the bullet and still maintain, for instance, 21 BHN or 20 BHN, whatever it was when it was a raw bullet after water quenching it. So here's what I come up with. I powder coated them just like I always do, or just how you always do. You can powder coat them any way that you want. If you're putting them in your tumbler, if you're spraying it on, I don't care. It don't matter. I just do the shake it up in the bowl for just a minute, and you've seen my method. And so I just used my regular method, powder coated the bullets, throw them in my wire mesh basket, put them in the oven, set my temperature. First of all, let me give you exactly what I've done here, and then I'll give you some hints, tips, tricks, that kind of thing of what worked for me. Here's what we're trying to accomplish. We're going to bake our bullets under 250 degrees. That's what we want to do. I really feel like it needs to be under 250. I don't know if it's going to mess it up if it's a tiny bit more than that. I really don't. I'll learn more later as I go. But I thought I had plenty of information at this point just to come on here and give you guys this and maybe get some feedback. So baking the bullets under, powder coat them normal way, bake the bullets at under 250 degrees for 13 minutes is what I come up with. I know that's a weird number, 13 minutes. If it's 12 or 14, probably no big difference. There is a little bit of a difference on the size of your load. If you're putting a larger load in there, the temperature I've found needs to go up a little bit. If you're putting a very small amount of bullets in there, the temperature needs to come down a little bit. That's a fact that I've found. So baking them under 250 degrees. This is what the temperatures look like right here. This is what the temperatures look like for me. I'm going to show you this. You can freeze, pause, just so you can see. And then I'm going to tell you what this means. So you bake it under 250 degrees. I tested this with my PID controller that Johnny's Reloading Bench sent me as a gift. Thank you, Johnny, again. I put my PID controller and just touched the tip of it to the wire basket while it was in the oven, and at 5 minutes I was at 225 degrees. At 7 minutes I was at 240. Now this number right here to me was the most crucial. I think that we have at least half of our 13 minutes, or right at half of our 13 minutes needs to be over 240 degrees to 250 degrees. Alright? So at 7 minutes I was at 240. At 11 minutes I was at 244 degrees. I just kind of wrote this down, and I've done this several times, and this is the method that seemed to get the job done at the lowest temperature. So my idea is to keep the temperature of the oven as low as possible, and limit the amount of time that the bullets are exposed to the heat. So that's the theory that I'm working on here. So and I'm positive that you guys are going to find differences here that work for you, no problem, no problem. But this seemed to be the crucial number. At 7 minutes, I really needed to go ahead and be at 740 degrees at least. And so I originally at my lowest, I set it at 200, and my oven was actually over by, like, you know, on a small batch, it was over like 30 degrees already. So and then after putting a big batch in there, I had to set it to like 250 degrees. So I was actually setting my oven between 200 and 250 degrees depending on the amount of bullets that I had in there at one time. I'm giving you this information so that you can understand that, you know, there's changes to be made based on your situation and your oven. But at 12 minutes, I was at 247 degrees Fahrenheit, and all of these degrees that I'm mentioning is in Fahrenheit. My highest temperature was at 249 degrees on my PID controller when I took the bullets out. So now let's see. Okay. So I told you I baked the same bullets from the same batch at 400 degrees for 20 minutes, and my BHN was like 11 or 12, and then the same batch, and it may be a little bit higher right now. It may eventually work its way up to 14, 15, 16, somewhere in that area. But the batch that I done, let's say, okay, oh yeah. Another thing I wanted to mention. All right, now you guys know that I don't normally, when I pull my bullets out of the oven, water quench them. You know, some people like doing that. They feel like it, you know, helps break the bullets apart. I've not seen a big difference there in pulling the bullets apart, so I've done it a few times, and then I just didn't do it no more. But in this case, I have found that whenever I take my bullets out of the oven, and I'm going to do a follow-up video on this subject, and I'm going to show you the process, how I do it, and obviously, because that's what I do, I'm going to do a video on it. But whenever I pulled them out of the oven and flipped my basket over, instead of all the bullets sticking, they just kind of fell out of the basket. All right, so that was something that was different. And then I noticed that you know, but still some of the bullets were stuck together like they normally are. So then what I done is I decided I would go ahead and do another batch, and I would this is after I perfected my method here. I'd do another batch, and I'd go ahead and drop them in water, and I'll tell you, man, they just all fell out. I mean, like nothing, you know, because whatever, you know, they just needed to be cooled down right away, and they did. You know, whatever was stuck together just broke apart. It was perfect. So with this method, putting them in water afterwards really worked well. So just throwing that out there for you guys, trying to give you everything that you need to get started right away. And then I also tested the BHN after pulling the powder coated bullets out of the oven, water quenching them, and also letting them cool on their own and testing them. Now another thing to note is whenever I took them out without water quenching them, I did a big old batch of them. I'm just at random here, let you see them. I've done, you know, just a big old batch of them, and I don't know if you can see in this handful that I have here, but they might have some furries on them because I threw them on a towel, and some of the cotton from the towel stuck to it, and I'll show you an example of that right here. Just so you see everything, and you can see what's going on here. That's not a mark from baking it. That's actually, you know, from a towel. And then I used a cotton t-shirt. I used a cotton t-shirt, and again, you know, it wasn't as bad as the fluffy towel, but some of the t-shirt material stuck to the bullet, you know, before they cooled, that kind of thing. So they were kind of sticking to the t-shirt. Just so you know, they didn't necessarily, you know, I guess you could, you know, you could deduct from what I'm telling you that the bullet powder coat didn't cure. You know, it wasn't hard. Obviously, it's soft whenever we take it out of the oven anyway. We already know this, you know. But in this case, at this temperature, it actually picked up some lint from my towel and t-shirt. So that's when, after I did that, that's when I tried the water quenching. Okay, now the next question that you have, I'm trying to keep this video as short as possible and put this information out because I'll do a follow-up videos on the method and how I do it, and I'll show you that. But the next thing that I want to show you is, because you're asking, you're saying, well, you know, does the bullet bond well? You know, does the bullet bond well? I mean, you know, that's what I want to know if somebody's telling me this. So this one right here is just one of the glossy ones that I water quenched. It remained glossy because it didn't come in contact with the t-shirt. So let's take a look. Let's beat the mess out of it with a hammer. Whoa! I fired that one. There it is. Alright. That's the bullet. It's even hot in my hand right here. Thing heated right up, hitting it like that. You can see where I hit it with the plier, where I had it with the pliers right there. Alright. There's our trunk of the bullet. There, everything looks perfect. There's the bottom of the bullet. There's the top of the bullet. Does it bond, you ask? Yes, it bonds. I just, you know, I didn't never want to do this kind of method. Never thought to, just because I thought it was useless. Never tried it. Never would know. And I'm like, man, I'm gonna see what I can do. Now the next thing is, you see I have red bullets here. So for all of you guys that use Harbor Freight paint, you're like, well, the Ford Light Blue from Eastwood works. How about the Harbor Freight? Yep. There's a Harbor Freight bullet right there. Harbor Freight red. I used the same method. Same method, because I knew that you guys were going to be like, well, how about the Harbor Freight red? So, yep, Harbor Freight red works. And I actually did a kind of a shoddy job of coating them to begin with, and they flowed out perfect. Looked good. So, you know, what else do I have for you here? Yeah, you know, I mean, I tried, you know, I compared the regular way with the new way, beat the heck out of the bullets. You know, if you want to see what one, this is one right here that was done, well, you know what the bullet, look, let me just show you, I'll show you the difference between them. Alright. The one right here is the regular way, and this one is the new method. Alright? The new method, the old method. It's just, it's basically the same. I can't tell the difference. Matter of fact, I got them both in my hand here. And I don't know which one is which. So, I mean, this is just great news for us. You know, checking the BHN raw was the same difference. It just, you know, I was so relieved whenever that bullet come out, and I didn't just test one of them, I tested a bunch of them. over and over the same BHN with the raw bullet, same BHN, and over again the method of heating our bullets to 400 degrees. It's tempering them, it's annealing them, whatever you call it. It's softening the bullet. So so I was just relieved whenever this process came out and I got these results. And I've known this for a little while, and you know, just trying to clear my head and make sure I kind of dot my I's and cross my T's about the subject, you know, as best I can before I give you the information. So what it ultimately does is it gives us a whole nother layer of just more control over casting bullets and powder coating bullets and the hardness that we want. So that's really it. So whenever I showed you these beautiful bullets right here and you didn't see the difference, it's because you can't see the difference. But whenever you test them, you find out that there's something very different about these bullets. It's awesome. You know, I love it when this is one of my favorite things to do, is whenever I find some information that's just very useful for us. And I play with this stuff all the time, as you know. You know, this is Elvis Ammo's Redneck Research Laboratory, better known as Earl. So I love it when I come up with something that's just very useful. And you know, and here's the here's the information right there. That's the method right there. Alright, now I use my PID controller. I know all ovens are different. Setting it at 200, if you don't have a way to tell the temperature, I'd start there. And what you'll find is, you know, what will definitely happen is, I'll give you this much, that what you'll find is the bullets will not have a sheen on it yet. If they're not shiny yet, if the powder coat has not melted all down on the bullet yet, then you know it's definitely not ready. I mean, that's for sure. And then it won't be long after you see that shine on that bullet, like maybe, you know, just 5 minutes after it starts to shine. That's it. You know, it's done. So there's another method that I just dreamed up in my head that could work. That's my idea. YouTube, I hope you enjoyed this video. Please share this information, you know, because I know this is information that people will really enjoy, be able to use, get some good use out of it. Please share this video, share this information. I'll see you in the next video.